Okay, it's time for part 2 of mechanics, and the first thing we're going to look at is mass, which is the amount of stuff or matter in something. It's measured in kilograms and it's a scalar quantity. The greater the mass, the more resistant the object will be to a change in its velocity. In other words, it's going to have more inertia. Now weight is different. Weight is the force experienced by a mass due to a gravitational field, and it will change according to the strength of the gravitational field. In other words, your mass will be the same everywhere. Whether I stick you on the Earth or on the Moon, your mass will always be the same. But you will weigh less on the Moon than you do on the Earth because the gravitational field strength of the Moon is weaker. Density is a measure of how compact the matter is. It relates the mass to how much space it takes up, and it's what determines whether something will sink or float. So density equals mass divided by volume. Moving on to the centre of gravity. The centre of gravity of an object is the single point that you can consider all of the weight of that object to act through. An object will always balance around its centre of gravity. However, the centre of gravity will sometimes fall outside of the object. Speaking of which, this donut gives a perfect example. Where is this donut's centre of gravity? Well, if we assume the donut is symmetrical, the centre of gravity will be in the centre of the hole in the middle. It won't actually be in the donut itself, it will be in the hole in the middle. And how do you find the centre of gravity of an irregular object? Well, you take your object and you stick a plumb line on it, and then you hang it up by a certain point, and the plumb line will drop vertically downwards, and where it falls downwards you draw a straight line on the object. You take the same object, you move the plumb line into a different position and hang it up by a different position. And again the plumb line will fall straight down, you draw another vertical line where the plumb line falls, and now you should have two vertical lines on your object. And where those vertical lines cross, that is where the centre of gravity of that object is. Now, an object that is tipped reaches a critical angle, beyond which it will topple over. So if we look at the diagram, we can see that the object will topple over if a vertical line drawn from its centre of gravity falls outside of its base area. And that is the end of part 2.
Created using Powtoon.